Tissue regeneration, or how do cells know when they should divide and grow? Cell growth has got to be balanced. Cell growth happens throughout the life of organisms, and it's important for them to survive and function. For example, skin is an important part of our immune system. Remember, that would be something considered a barrier in your non-specific immune system. When damaged, it quickly regrows and prevents pathogens from getting into our body. Too much growth, however, can get out of control and can lead to cancer. Our bodies have to balance growing cells, replacing damaged ones, without growing too quickly because that could cause cancer to happen. Possible scenarios for cell growth. So there's obviously normal development when organisms transform from a zygote to an adult. Sometimes there's no growth happening. For example, humans who have limbs, born without limbs or do not regrow their limbs. Sometimes there's too much growth. Cell growth occurs in cancer cells or causes dysfunctional bodies to form. And there's regrowth. Cells regrow to replace cells that are lost or damaged in adult organisms. For example, your liver cells will regrow if you damage them. Normal development example of a salamander egg. So the zygote will divide into embryo tissue. Embryo will form a cavity inside. The heart, blood, and head and tail are gonna form. The larva hatches, and the limbs form at the larval stage. So you can kind of follow that starting on the bottom right around counterclockwise. Example of no growth. Human amputees. When we lose a limb, our immune system works to cover that area that has been damaged with new skin, and we will grow scar tissue over that region. However, we're not actually going to grow another limb. It will not function as it did in the past. Too much growth would be an example for human skin cells. Skin cells growing and dividing rapidly and are therefore prone to cancer. In the United States, rates of cancer are highest in skin tissue. That is why you should wear sunblock when you go outside. Again, with the regrowth example of salamander limbs remember their original shape and reform. If you look in the upper right-hand corner, we've got a salamander losing an arm, and then it grows back again. Salamanders transform nearby cells into stem cells, which then differentiate into muscle, blood, bone, and nerves. Axolotls, which are a type of salamander, can regrow their heart and their brain as well. So this is an amputated limb growing, and it's a time lapse. There's Mr. Salamander. This has got all of its bones and nerves on the inside and muscles. Oh, then we cut, well, that was violent. Then we cut off the arm. Instead of just stopping like a human would, it's actually going to transform some of those cells nearby into stem cells. And it's going to go into the wound area and start to regrow our arm if we're a salamander. There's that bone growing and the muscle and the nervous tissue. And we have a new arm. And we're good to go. Maybe don't hang out with the person who has the scissors anymore, though. Another regrowth example would be sea cucumbers. Sea cucumbers have the ability to eject their internal organs. Marine biologists think it might be a way to avoid predators, deal with stress, or get rid of parasites. Sea cucumbers de-differentiate, meaning their cells revert back to generalized cells that can then develop into any type of organ cell. This helps the sea cucumbers regrow the organs it ejected. So here we have the sea cucumber fighting with its gut. Isn't nature cool? Another regrowth example is antlers. Antlers on male deer help compete with other males and get a mate. Antlers are some of the fastest growing tissue of all animals. They can grow up to a quarter inch a day in white-tailed deers. That'd be like if we could grow 7 inches a month. Deer also have strong anti-cancer genes to prevent the growth of cancer cells.